Okay, so recording I have started. So we will start with the KCL statement, and then we will see some of the examples related to KCL, and then we will move ahead towards KVL, and we will solve some examples, right? So you can note down, according to KCL, in any electrical network, the algebraic sum of the currents, the algebraic sum of currents meeting at a point or junction, meeting at a point or junction is zero. Or in alternate way, you can say that the total current leaving a junction or a node is equal to the total current entering that junction. Both are same thing. So for example, you can consider, let us consider this A point as the junction or node of any electrical network, and let us consider different points are uh, there which are coming, or you can say terminating from this point A. If this is the direction of current I1, if this is I2, if this is I3, I4, and let us consider this as I5. So what we can write according to this KCL is that uh, what I have told you, that the summation of currents or total currents leaving a junction is equal to the total current entering that junction. So out of these 5 currents, you can see that I1 and I4 are entering the junction, whereas the remaining 3 currents I2, I3 and I5 are leaving the junction. So according to this KCL, I1 plus I4 will be equal to I2 plus I3 plus I5, right? ठीक है. So this is the statement of KCL. Or if you go by this statement, the algebraic sum of the currents entering at a point or junction is zero, then also you can write it in this way. Suppose this is I1. If we consider the polarity of the current entering the node is positive, then again you will have plus minus I2, because this current is leaving the junction, so obviously it will be minus. Then again plus minus I3 plus I4 plus minus I5 will be equal to 0. So both are same thing, the same result you will get. That is, incoming currents will be equal to outgoing currents. This is the statement of KCL, right? Now, based upon this uh, statement, you can solve the different, or you can apply this concept in any complex electrical network. So for example, let us consider a simple electrical network in this form, where we have a node A, and then suppose this is any source, then again we have a capacitor as an element of this circuit, and in this arm, let us consider we have a simple resistor having resistance R. If the inductance of this inductor is 4 Henry, current flowing through this I1, and if V1 is the voltage across this inductor of 4 Henry, I2 is the current flowing through this arm, I3 is the current flowing through the capacitor, and the voltage across the capacitor is suppose V3 having capacitance of 2 Faraday, and if I4 is the current flowing through resistor R, then, and some values are also mentioned, like suppose I2 is given equal to 5 e to the power minus 2 t, then I4 is also given 3 sin t and V3 is also given 4 e to the power minus 2t, right? So using KCL, Kirchhoff's current law, find V1, that is voltage across the inductor of 4 Henry, inductance 4 Henry. तो इसमें अप्लाई करो KCL, देखो क्या आता है, बताओ. First of all, you write the expression of the currents using KCL. I1 I2 I3 में क्या रिलेशन होगा, ये पहले बताओ.
Sir, I1 plus I2 plus I4, no, I1 plus I2 plus I3 is equal to I4.
Yes, I1 plus I2 plus I3 will be equal to I4. That is, total current entering the node A will be equal to the total current leaving the node. So I1, I2 and I3 are entering the node and I4 is leaving the node. So this will be the current expression. Now we have to find out this V1. So you should know that voltage through any inductor, suppose there is inductor of inductance L, so voltage through that inductor will be L di by dt, ठीक है, minus L di by dt according to Lenz's law. So first of all, our objective should be to calculate this current I1, because the value of L is already given, which is equal to 4 Henry, and if we know the value of I1, then this will be L di1 by dt, right? तो इस एक्सप्रेशन को यूज करके इक्वेशन 1, सपोज ट्राई टू फर्स्ट ऑफ ऑल कैलकुलेट I1. कैलकुलेट करो क्या आता है I1.
Sir,
Yes,
3 sin t minus 5.
3 sin t
3 sin
11 e to the
minus
power minus 2.
क्या.
Sir, 3 sin t plus 11 e to the power minus 2t.
Okay, you have calculated that. So I1
Yes, sir.
will be equal to how much? 3 sin t
Plus 11 e to
11.
the power minus.
Okay. So all of you got this expression of this current I1.
Yes, sir.
Okay. So now, if we want to calculate the expression of V1, then this will be simply minus L di1 by dt, right? Otherwise, if it is asked to calculate just the magnitude of V1, then it will be L di by dt, di1 by dt. So simply it will be 4 3 cos t, then it will be how much? Minus 22 e to the power minus 2t, right? So this will be the value of voltage, magnitude of voltage across the inductor of inductance 4 Henry, right? समझ में आया ये सबको? So in this way, we can calculate, we can apply the concept of KCL in any electrical network. Here it is a very simple example we have considered, but later on you will see that when there are multiple branches or multiple loops in any electrical network, then you may have to use different concepts simultaneously, like KCL also you will have to use, you may have to use, then KVL you may have to use. So several theorems simultaneously can be used in order to solve any electrical network with lesser computation, right? Now we will see this Kirchhoff's voltage law, right? So according to this Kirchhoff's voltage law, algebraic sum of the products of current and resistances in in each of the conductors in any closed path plus the algebraic sum of EMFs in that path is 0. Right? Means algebraic sum of the product of current and resistances. What does it mean? It means that voltage drop, right, across the conductor or the different parameters of the circuit. So let us consider if only resistor is used as a parameter in any electrical circuit, then the product of current along with that resistance value will give you the voltage drop across that resistor. So the algebraic sum of all the voltage drop in any closed path along with the different EMFs, algebraic sum of different EMFs in that path should be 0. So indirectly you can say that summation of IR, suppose there are n number of resistors in any electrical circuit or any electrical path, closed path, then summation of IR plus summation of EMF, this should be equal to 0 in any closed loop or path, right? Now algebraic sum, what does this algebraic sum means? Algebraic sum is the sum which takes into account the polarity of the voltage drop. You will have to consider the polarity of the voltage drop, with whether it will be a minus IR or plus IR, or whether the value of the source or EMF source you will consider it as minus V or plus V. It will depend because we are considering the algebraic sum, right? So let us try to understand this law with the help of a simple electrical circuit. So let us consider this electrical circuit. Can you see the screen? स्क्रीन पे दिख तो रहा है सब कुछ या कुछ डिले हो रहा
Yes,
है?
sir.
नहीं सर दिख रहा है सर.
Yes, sir.
Okay, okay, thank you. Suppose this is a part of any large electrical network. We have considered part where we have taken this section of an electrical circuit. Let us represent it by R1, then R2, R3, then R4. This is E1, then this is E2. Then suppose if this is A point, this is B, this is C, this is D, and the various currents in the different branch of this circuit is I1, then I2, then suppose in this direction I3. You can consider any direction. We are just taking a random example, means how to write the KVL equation or how to apply the KVL in any electrical circuit, closed path of any electrical circuit. So now the application of this KVL also depends upon the direction of travel. Means whether you want to move in this closed path in clockwise direction or in anti-clockwise direction. So first of all, let us consider we are moving in clockwise direction. That is, this is the direction of travel, right? So let us start from this point A, then move in the clockwise direction and again reach up to point A. So how to write the KVL equation, right? So before that, uh, you will have to understand something that you will have to understand the concept of rise and fall in voltage. These are actually very basic thing. I hope that all of you know, but just I am repeating these things in order to make you understand in a better way. बाद में कोई दिक्कत नहीं आए समझने में. Rise and fall in voltage, ये concept समझना होगा. So a rise in voltage should be given as a positive sign, right? And again fall in voltage should be given as, this is just a convention, negative sign. ठीक है. इसका मतलब ये है कि suppose if there is a voltage source, simple DC voltage source or battery, then you know that the a smaller plate of this battery is represents the negative plate and the larger one represents the positive plate, right? So suppose if we are moving from left towards right, then there is a rise in voltage because we are moving from negative plate towards the positive plate, so there will be a rise in voltage. So this should be given, and if this is the voltage magnitude V, then uh, you will have to consider plus V, right? But if you are moving from right towards left, then ultimately you will go from higher potential plate towards the negative potential plate. So in this case you will have to consider minus V, right? This is one thing. And now sign of if we consider the sign of potential drop across the resistor having resistance R, so if we consider the sign of IR drop in any loop, then if we go through a resistor in the same direction, so let us consider a resistor of resistance value R, and if I is the current flowing through this resistor, and if we go through or travel through the resistor in the same direction as the direction of current, that is in this case from left towards right, then there is a fall in potential, fall in potential. Why? Can anybody tell?
Sir,
Sir,
current is the
because
flow of resistance current in the current direction. The voltage is fall.
Hello.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
कुछ नेटवर्क प्रॉब्लम हो गया था. So can you see the screen now?
Yes, sir.
Yes.
Okay, thank you. So if we are moving in the same direction to that of the current, so there will be a fall in potential, because you should know that the current always flow from the higher potential towards the lower potential. So in this case, you will have to consider the negative polarity, negative drop, right? ठीक है? और second case, मान लो ये second था, when we are moving in the same direction as that of the current. Now second case, if in the same register for the given direction of current, if we move or travel in the opposite direction of current, then you will have to consider the positive polarity of the IR drop, because we are moving from the lower potential up to the higher, towards the higher voltage source, lower voltage towards the higher voltage. So there will be a gain in the voltage. That's why we will have to consider the positive. So now, using these two concepts, you try to apply the KVL in this circuit, in suppose figure 1. लिखो, A से start करो, and let us consider clockwise direction. So in this register, current is flowing in this direction from left towards right, or from A towards B, and we are moving in the same direction. So what will be the drop? बताओ.
I1 R1.
So minus of I1 R1.
Minus I1 R1.
R1, right? Just I have mentioned these things. Then again, in this second section, or second limb of this network circuit, closed path, I2 is the current flowing through the resistor R2 from B towards C, and we are moving in the same direction of the current. So again, it will be
Minus I2 R2.
Minus I2 R2.
Minus I2 R2.
right. Then what about this voltage source?
E2.
Minus E2.
Minus E2.
Right. It will be minus E2, because we are moving from positive plate towards the negative plate. So it will be minus E2. Now, what will be the drop across R3?
Plus
R3 के
I3
across,
R3.
Plus R3 I3.
yes, plus I3 R3, because in this case we are moving in the opposite direction of the current. I3 जो है, that is flowing from D towards C, but we are moving in the opposite direction of I3. So that's why positive drop. Now again, what about this E1
Plus
source?
Plus E1.
This will be plus E1. And
Yes.
what about the drop across R4?
Minus
Minus
I4
I4.
Minus I4 R4. So this will be equal to 0.
R4.
So this is the equation after application of the KVL. Right? I hope all of you understood this.
Yes, sir.
Okay. So now let us see some examples of the KVL. First one is the very basic one. Just I want to see whether you have understood or not. So let us consider this simple circuit having only different sources, DC sources in it. If this is suppose A point, this is B point. Suppose there are different sections also in this circuit. This is a part of any larger electrical network. Suppose if this is Vs, is the voltage across this open circuit terminal A and B. If the magnitude of the different sources are 20 volt, then this is 50 volt, this is 30 volt, this is 10 volt. So tell me what will be this vs का वैल्यू कितना होगा बताओ.
Sir,
So it's 0.
How much?
sir, 30 volt.
30 sir, 30 volt.
One answer is 60, another one is 30 volt. Okay, let us see. तो मान लो कि हम लोग जो है सो यहाँ से स्टार्ट करते हैं.
सर 30 है.
Okay, let us see it. We will start from this A and we will reach this point B, and let us consider we are moving in this direction. So VA, then minus 30 because we are moving in this direction, then plus 50 plus 20 minus 10 will be equal to VB, or VA minus VB will be simply how much? 50 to 70 minus 40, that is 30 volt. So VA minus VB is basically your VS. So this will be 30 volt, right? पोलैरिटी की अगर बात करें सो इस प्लेट का पोलैरिटी या ए का पोलैरिटी क्या होगा, पॉजिटिव या नेगेटिव? किसका पॉजिटिव किसका नेगेटिव होगा?
ए का पॉजिटिव.
राइट, ये
सर वो
पॉजिटिव
तो
होगा, ये नेगेटिव.
कंसिडर करने पे डिपेंड करता है ना.
ये कंसीडर तो किया मैंने कि ए से हम लोग मूव कर रहे हैं,
ओके
बी पे जा रहे
यस
हैं.
या
We have considered, so this will be this A and B will have this set of polarity. So now second example, second example तुम लोग देखो, एक खुद से ट्राई करो. Example number 2. So this is a circuit. Then you have here a voltage source in between the connecting arm. Suppose this is A, B, C, D. This is of 20 volt, 9 ohm, 5 ohm, 6 ohm. This voltage is suppose 5 ohm. This is E, F, G, H. 7 ohm, 40 volt, 8 ohm. Right. So here, let us find out the value of. Let me check this source value. What is the source? 29.5. This is of 10 volt. Okay.
सर
So here, hello.
सर वो फर्स्ट क्वेश्चन में सर बी पे पॉजिटिव प्लेट होनी चाहिए थी ना
किसमें?
सर? जो ऊपर वाला क्वेश्चन है सर उसमें बी पे पॉजिटिव प्लेट होनी चाहिए थी.
क्यों?
सर क्योंकि 30 कम करना है ना, तो मतलब सर जब बी से जाएंगे तो अगर बी की तरफ पॉजिटिव प्लेट होगी तभी तो सर -30 आएगा.
नहीं -30 कहाँ आ रहा है, +30 आ रहा है. देखो हम लोग मूव कर रहे हैं कहाँ से. वी हैव एज्यूम्ड दैट this A plate is at higher potential, right? एज्यूम किया हमने, तो हमने मूव किया A से B की तरफ हम लोग गए, तो VA स्टार्ट किया, VA को कंसीडर किया पॉजिटिव, राइट, प्लस VA लिया. देन अगेन फ्रॉम पॉजिटिव टू निगेटिव आए, फिर निगेटिव से पॉजिटिव आए, देन अगेन निगेटिव टू पॉजिटिव. इस डायरेक्शन में मूव किया, एंटी क्लॉकवाइज डायरेक्शन में. And we have considered the negative polarity of point VB, V. That's why इसको लिखा था हमने क्या, डायरेक्ट इक्वल टू VB, बट इट इज एक्चुअली माइनस VB इक्वल टू 0. अगर ये वैल्यू आता -30, VA माइनस BB अगर -30 आता, then it means that A is at lower potential, right?
ओके सर.
Okay. So here in this circuit, in the second circuit, you try to find out VCE and VAG. ये दो चीज पता करो इस सर्किट में, जल्दी जल्दी करो। इसमें देखो, इसमें तुमको हो सकता है ये कंफ्यूजन क्लियर हो, जो पॉजिटिव निगेटिव वाला है।
सर VCE 0 आ रहा है।
क्या आ रहा है?
Zero, sir.
VCE 0 आ रहा है।
यस सर।
VCE इज इक्वल टू 0, ये गलत है, कुछ ठीक से सॉल्व करो। चलो स्टार्ट करो पहले।
सर
अच्छा
5
ये
वोल्ट,
बताओ।
सॉरी
हाँ
सर
सर
5
बी
वोल्ट।
से एच में करंट 0 हो गई।
VCE is 5 वोल्ट।
अच्छा एक चीज बताओ, चलो स्टेप बाय स्टेप देखते हैं। मान लो कि ये लेफ्ट वाला जो है, इसको हम मानते हैं फर्स्ट सर्किट एंड इसको मानते हैं सेकेंड सर्किट। तो first of all tell me what will be the value of current flowing through the first circuit. Let us consider it as I1 and let us consider the current flowing through the second circuit is a I2. So what will be the magnitude of I1 and I2? पहले ये बताओ।
सर I1 1
I1
1
1
एम्पियर
एम्पियर।
So
and I2 is 2
I1 will
एम्पियर।
be equal to 20 by 6 plus 5 11 plus 9. It means you want to say that total I1 current will only circulate in circuit 1,
यस सर।
right?
यस सर।
Okay, 6 plus 5 plus 9, that is 1 ampere. Similarly, if we calculate I2, then again you want to say that I2 will only circulate in this path, in this closed loop. That is 40 by 8 plus 5 plus 7. That is 2 ampere, right? So it means that the value of the current flowing through this BH part of the circuit will be how much? 0,
So 0.
right? तो यही चीज मैंने लास्ट क्लास में एक समझाया था कि whatever the current will start flowing through one part of the circuit, suppose ये पॉजिटिव प्लेट जो बैटरी का है, यहाँ से अगर I1 करंट स्टार्ट हो रहा है, the same current I1 should reach from the negative plate of the battery. ठीक है, कहीं लॉस नहीं होना चाहिए करंट का। सेम थिंग इज एप्लीकेबल इन सर्किट 2 आल्सो। So now we know the value of I1 and I2. So now we calculate, let us start from this point VC. VCE means how, what? VCE means VC minus V. C और E के बीच का पोटेंशियल डिफरेंस ये होगा। तो let us start from this C point and move in this direction. जो मैं शो कर रहा हूँ एरो, तुम कोई भी डायरेक्शन ले सकते हो, वो कैलकुलेट करके देख सकते हो। ठीक है, इस डायरेक्शन में मूव कर रहे हैं। So we see, then here we are moving in which direction of the current? I1 जो है that is flowing in the clockwise direction.
Opposite direction.
So we are moving in the opposite direction. So this will be plus
Again.
5
Plus
into
1. Plus 5 into
5 into 1. Then here across
Six.
this voltage source of 10 volt, it will be
minus of 10.
minus of 10 volt. Positive plate से negative की ओर जा रहे हैं। Now what about the drop across this resistor of resistance 5 ohm?
So it's plus 10.
Right, it will be 5 into 2, 5 into I2, and we are moving in the opposite direction of I2, right? So minus VE will be equal to 0. So from here we can write VC minus VE will be equal to
minus 5.
कितना होगा?
Minus 5.
minus 5 volt. So this will be minus 5 volt. इसका मतलब क्या हुआ? It means that E point is at higher potential कम। ठीक है, अब देखो, अब इसमें कोई बोल सकता है कि हम इसी डायरेक्शन में क्यों जाएं, पहले हम सी से जो है डी जाएंगे, फिर डी से ए, ए से बी, फिर इधर जाएंगे, फिर इधर जाएंगे। मतलब वही हो गया कि यहाँ से वाराणसी जाना है तो पहले लखनऊ जाएंगे और उसके बाद फिर जो है सो अयोध्या होते हुए घूम फिर के कहीं से जौनपुर होते हुए वाराणसी पहुंचेंगे। तो यू कैन डू दैट, ठीक है, तो करके देखना सेम वैल्यू आएगा। तो सिमिलरली यू कैन ऑल्सो कैलकुलेट VAG। ए से स्टार्ट करो, जी तक जाओ, जो डायरेक्शन मन है कंसीडर करो, यू विल गेट द सेम रिजल्ट, राइट? So I hope KCL KVL concept is clear to all of you. So now you can solve any example. You can take the examples from any textbook and you can try whether you are able to solve or whether you are able to apply these two concepts or not. हम भी कुछ ट्यूटोरियल सीट में कोशिश करेंगे अपलोड करने की, लास्ट वीक नहीं कर पाया था। So moving ahead, any confusion किसी को अभी तक?
No, sir.
No, sir.
Okay. So now we will see another method of solving equations with n number of unknowns in any system, that is known as the determinant method. So solving equations with, suppose for example, consider with two unknowns. It may be 3 also, 4 also, depending upon the system configuration or circuit configuration. So let us consider the two equations as ax plus by is equal to c. मान लो ये इक्वेशन नंबर 1 है and another equation is dx plus ey is equal to f. मान लो ये इक्वेशन नंबर 2 है, राइट? सो अब इसी में मतलब क्यों इस तरह से हम लोग ये पढ़ रहे हैं, तो मान लो कि एक तो सपोज फॉर एग्जांपल वी हैव दिस सेट ऑफ इक्वेशंस 4i1 minus 3i2 is equal to 1. In terms of current we have two variables i1 and i2, and another equation suppose 3i1 minus 5i2 is equal to 2 ये है। यहाँ सिंपली जो है सो मैथमेटिक्स अप्लाई करके जैसे तैसे सॉल्व करके जो है, दो इक्वेशन है, दो अननोन है, वो हम लोग कर सकते हैं कैलकुलेट। बट इन केस ऑफ suppose 3 or 4 number of unknown currents i1 i2 i3 and i4, this method is not that much efficient in terms of calculation. Complexity जो है वो ज्यादा हो जाता है solving the equations simultaneously. So in that case we use the matrix form or matrix method to solve the or calculate the various currents in any electrical circuit. So after applying KCL KVL you can write these equations. अभी बताया है कि जैसे कि KVL अप्लाई करोगे या KCL अप्लाई करोगे, you will get the expression of the different currents with the help of different equations in the form of different equations, and after that you have to apply this method, determinant method. Sometimes जैसे क्वेश्चन पूछा जाता है, in that you will see that the method name is also mentioned. Use determinant method or use nodal analysis method or mesh analysis method or network theorem method to solve this circuit. So in that case you will have to use that method only which is mentioned in the question, right? So the first step is to write these two equations in the matrix form. ये सब मैथमेटिक्स में तुम लोगों ने पढ़ा होगा, मैथमेटिक्स में पढ़े होगे मैट्रिक्स फॉर्म में कैसे लिखते हैं इक्वेशंस को. सो दिस विल बी a b d e, these are the variables x and y in this case, and this will be equal to the constants. ठीक है. So therefore the common determinant is, ये होगा सिंपली इस मैट्रिक्स का ए बी डी ई, इसका जो डिटर्मिनेंट निकालोगे सो यू विल गेट ए माइनस बी डी, राइट. नाउ सेकेंड स्टेप इज, step 2 is suppose for finding the determinant for x, for finding the determinant for x variable, you have to replace the, suppose delta 1 is the determinant for this x variable. So in this case, you will have to replace the first two elements of the matrix by the constants of the matrix, that is CF, B, E will be remain unchanged. So if we calculate now the determinant for this element, then this will be simply CE minus FB. Right. Now similarly, for finding the determinant for y, just replace these things. AD will be unchanged, replace BE by CF. Now if we take the determinant value, then this will be simply AF minus CD. Right. So now here you have to, in step 4, you have to apply a rule that is known as Cramer's rule. मैथमेटिक्स में पढ़े होगे, जब मैट्रिक्स पढ़े होगे तो. So Cramer's rule, using Cramer's rule, using this Cramer's rule, you can now calculate x and y variable, जो कि इस केस में है इक्वेशन नंबर 1 and 2 में. So x will be simply equal to delta 1 by delta, and y will be equal to delta 2 by delta. डेल्टा 1 ये है, डेल्टा 2 ये है, और डेल्टा जो था वो कॉमन डिटरमिनेंट था, जो ओरिजिनल सेट ऑफ इक्वेशंस वी विल रिसीव आफ्टर अप्लाइंग केसीएल एंड केवीएल, तो वहां से आएगा. तो अब जैसे कि यहाँ पे सिंपली सपोज इसी दो इक्वेशन के लिए जो हमने करंट का एक्सप्रेशन कंसीडर किया था, so for that you can apply this method, determinant method, in order to obtain the value of the different currents flowing through the network. तो यहाँ पे तो डायरेक्टली दिया हुआ है करंट का वैल्यू, but in some case you will have some circuit, electrical circuit, then they will ask to calculate the value of the different currents through the network using determinant method, right? तो ये मेरे ख्याल से समझ में आया होगा. तो इसमें एक तुम लोग लिख लो, उसको खुद से सॉल्व करना. आई विल जस्ट गिव यू 3 इक्वेशंस, like I1 plus 3I2 plus 4I3 is equal to 14. Then I1 plus 2I2 plus I3 is equal to 7. And third one is 2I1 plus I2 plus 2I3 is equal to 2. So these are 3 equations. Calculate I1, I2 and I3 using determinant method, right? ठीक है.
Yes, sir.
हेलो.
Yes, sir.
Yes, sir.
Yes, sir.
समझ में आया ये पूरा
Yes,
चीज
yes.
जो आज हम लोगों ने पढ़ाई किया?
Yes, sir.
ओके. तो इसको सॉल्व करना, फिर बाकी हम लोग आगे की क्लास में देखेंगे. तो आज जैसे कि 5 से 6 करना है क्या क्लास? क्योंकि
सर,
ट्यूसडे वाला क्लियर नहीं है, तो तुम लोग बताओ, अगर इफ यू आर अवेलेबल देन वी कैन हैव इट नेक्स्ट।
सर
Yes, sir.
5 से 6 में तो नहीं हो पाएगा। आप सर पहले कभी करना हो तो कर लीजिए।
क्या बोल रहे हो?
सर 5 से 6 में तो सर वो गेम्स टाइम होता है ना, तो
5 से 6 कौन सा गेम्स टाइम होता है?
सर उसके बाद तो अंधेरा हो जाता है।
अच्छा ये नया चीज तुम बता रहे हो।
यस सर।
एनीवे जो भी तुम लोग मेजोरिटी का हो मुझे बता देना, क्योंकि क्लास तो जो शेड्यूल होता है वो 6 बजे तक है तुम्हारे टाइम टेबल के हिसाब से, तो वो देख लो, क्योंकि हम लोग कुछ क्लास जो है सो मिस किए हैं अभी पिछले वीक में, पिछले वीक में, तो उसको कवर करना था। एनीवे देख लो तुम लोग। बाकी ट्यूसडे वाला जो 9 से 10 क्लास है वो पॉसिबल नहीं है, उसका टाइम जो है सो कहीं सेट करना पड़ेगा।
सर EC2 का सर 3 बजे से फ्री है सर, ट्यूसडे को 3 से 5 फ्री है हमारा।
4 to 6%.
ट्यूसडे को
यस सर।
3 से 5,
यस सर, यस सर।
तो 4 बजे से रखा जाए तो।
सर मैं EC1 के CR से कंफर्म करके सर आपको मैसेज कर दूंगा सर, DM में सर।
नहीं लेकिन तुम लोग तो ECA के हो ना?
सर मैं EC2 का हूँ सर, कुछ बच्चे EC2 के हैं, कुछ बच्चे EC1 के हैं, तो फिर सर टाइम टेबल थोड़ा हल्का सा डिफरेंस है।
नहीं 1 2 से नहीं, मतलब थ्योरी क्लास तो ECA और ECB का होता है ना, लैब में 1 2 3 4 है ना।
यस सर, बट अदर लैब्स हो सकती है ना उस टाइम में, ट्यूसडे को 3 से 5 में उनकी, तो फिर टाइमिंग मैच नहीं करेगा ना, तो फिर सर।
चलो देख लो जैसा हो वो
Sir,
मतलब।
Tuesday 4 to 5 is comfortable for EC1 also.
ओके, तो क्या मतलब कल 4 से 5 का रखा जाए तब क्लास?
यस सर, यस सर।
Sir, 3 to 4 is comfortable for you?
नो 3 to 4 इज नॉट कंफर्टेबल।
Okay, sir, then 4 to 5 is
4 to
fine.
5 will be fine. Okay then, thank you everyone.
Sir,
हाँ,
are you following any book if you can share with us?
there are actually different books, right? For this is a very basic course, like there are different books available in the market or in the library, like the book by Abhijit Chakravarti, Haldar and Chakravarti. Then वो पढ़ सकते हो, या फिर कोई भी किताब पढ़ लो। सर्किट थ्योरी में ऐसा है कि नेटवर्क एनालिसिस में कुछ भी पढ़ लो, कहीं से भी पढ़ लो, जहाँ पे मैक्सिमम न्यूमेरिकल मिले वहां से पढ़ लो। हाँ,
Sir, I meant if you have any PDF, so please share it in team.
PDF?
Yes, if you have any PDF, then please share
No, I
it.
don't have any PDF actually,
Okay, sir.
because this subject I am teaching first time. This is a very basic course, and for electronics batch I am teaching the first time, so I don't have any existing notebook. I am also means looking at different books available, or I'm looking at the different contents from the website, so you can follow any book. I don't have any objection there. You can, whatever you is suitable to you, you can do that.
सर
हम्म।
सर जो अभी आपने क्वेश्चन दिया उसमें सर जो कॉमन